All right, last day of reviewing systems. So today we're doing our three variable systems. We got three variables, we have three equations. So this is our x, y, and z. So I'm going to do, I'll do two by hand, and then I will show you how to use a system solver at home, since our students here on campus do have the TI software. I know that a lot of you were asking, how can I do this at home without the system solver? So I'm going to show you how to use a system solver, but I am going to show you also how to do it by hand one last time. So this is why that blank page is there right next to this. I'm going to start with the first one. So I need to write it because I'm going to zoom in over there. So 3x plus 5y plus 3z equals negative 10. Negative 4x minus 6y plus 3z equals 14. And then 3x plus 6y plus 3z equals negative 9. So I'm going to solve this by hand, so I'm not going to use a calculator. I see that I can use elimination here. So that's what I'm going to do. I'm going to use elimination and get rid of that y variable. So negative 4x minus 6y plus 3z equals 14. And 3x plus 6y, I see that they're already opposites, so I don't have to change anything, equals negative 9. And I'm going to combine these two equations. I get negative x, no more y's, plus 6z equals 14 minus 9, which is 5. I like to get the simplest form, so the simplest I see is by moving 6z over, so that we don't have to divide by any coefficients. So then I have negative 6z plus 5, but I have a negative 1, so I do have to divide by a negative 1 as a coefficient, but that's easy division because all it does is change everything's sign. So x equals 6z minus 5. So now I have x in terms of z, and I can plug that into any of my equations. I'm going to plug it into the first one, just because it does not matter which one you plug into. So we have 3, 6z minus 5 plus 5y plus 3z equals negative 10. I'm going to distribute that 3, so I get 18z minus 15 plus 5y minus 3z equals negative 10. And then I'm going to combine my like terms, 18z minus 3z, 15z minus 15 plus 5y equals negative 10. And I want to solve for y so that way I can get y in terms of z as well. So I'm going to move the 15z over. Negative 15 plus 5y equals negative 15z minus 10. And I need to move the 15 over because I just want y, remember? And I get 5y equals negative 15z plus 5. And then divide everything by 5. And y equals negative 3z plus 1. So now I see that I have x and y in terms of z. So I'm going to plug both of these into either one of my equations. It does not matter. I'm going to use the last one since it has all positives. It doesn't matter though. So I have 3, 6z minus 5 plus 6, negative 3z plus 1 plus 3z equals negative 9. So now I'm going to distribute what I need to distribute and then combine like terms. So 18z minus 15 minus 18z plus 6 plus 3z equals negative 9. 18z minus 18z is going to cancel each other out. Negative 15 plus 6, negative 9, plus 3z equals negative 9. Add 9. 3z equals 0. Divide by 3. And z equals 0. So z equals 0, I'm going to plug into x equals 6z minus 5. So x equals 6 times 0 minus 5. X equals minus 5. And into my y equals negative 3 times 0 plus 1. 1. So my solution is negative 5, 1, 0. So remember, with our 3 variable systems, we should have an x, a y, and a z in our answer. So we get negative 5, 1, 0. So it is a rather lengthy process when we're solving it by hand, but I enjoy it. So then I want to do another one, but I want to show you how to use the system solver on the next one. So bring my keyboard up. So I want to do, alright, so unfortunately, I just tried to record my screen with the internet and it said that I cannot do that. So if you want to see how to use a system solver, then I am going to need you to join a Zoom. So on Zoom, I have shown them before how to use the system solver. So if that is something you are interested in, then I am more than happy to show you on Zoom. That way I can share my screen on there. So I'm going to do a word problem. So number 9 says, May and Ryan each improved their yards by planting rose bushes and geraniums. They bought their supplies from the same store. May spent $181 on 11 rose bushes and 12 geraniums. Ryan spent $159 on 14 rose bushes and 1 geranium. So on these word problems, the main thing, which is what I also said on a Zoom before, the main thing that we're testing is, can you set them up? So yes, you do have access to these wonderful calculators and these beautiful system solvers on the internet, and that's good and lovely, but if you can't set up these word problems, then you are out of luck. So on these, we need to assign variables to each of our variables. So if that makes sense. So each of the things that are changing in the problem will be assigned a letter. So like in this problem, he's got rose bushes and geraniums, rose bushes, geraniums. So I see that there's only 2 variables. So for rose bushes, we'll say that's our x. And geraniums are our y. So we're going to have 2 equations, and we need money equals money. Doesn't that make sense? If you're adding money together, you should get money in the end. If you're starting with no money, how does it make sense that your total is money? So each of these variables now has to be the cost of a rose bush and the cost of a geranium. So May spent $181 on 11 rose bushes and 12 geraniums. So she had 11 rose bushes, so 11 times the cost of a rose bush plus 12 times the cost of a geranium equals how much she spent total, which was 181. And then Ryan spent $159 on 14 rose bushes and 1 geranium. So now we've set up our system, and then from here, to find the cost of 1 for each of them, we would use a system solver. If you don't know how for the internet, join a Zoom. And I am more than happy to show you. Because I don't expect you to work these problems 100 million times with 18 bajillion different variables. I expect you to be able to know the process, and then I expect that you know how to set up your problems. So like we did on number 1, we did do it all by hand, and you should know that process, that you either use elimination or substitution, and then you go back in and work it again and work it again until you have all 3. But I'm not going to ask you to do that on all 1 through 8. So for my students' sake, this is the example. And I'm going to ask you to do this one by hand, and this one by hand, and then these and these. Use the system solver to get that good practice in. So I do need 2 of them done by hand, and then you've got the system solver for the other ones. And then for the word problems, all of them need to be done with a system solver, but I do have to see your equation set up. So we're going to do another one. I don't want to do another one where it's the cost of something though. Well, it looks like they all are cost of something. So we'll just do the next one and we'll set it up. So the school that Julia goes to is selling tickets to the annual dance competition. On the first day of ticket sales, the school sold 6 senior citizen tickets and 2 child tickets for a total of $36. Okay, that only has 2 variables. Let's see if we have one that has 3. Alright, number 14. This has 3 variables: souvenir hats, t-shirts, and jackets. So the cost of a hat is our X. The cost of a t-shirt is our Y. And then the cost of a jacket is our Z. So we have 3 different variables, which means we need 3 different equations. So 3 hats, 2 shirts, and 1 jacket is $140. 2 hats, 2 jackets, oops, I missed shirts. 2 shirts and 2 jackets is $170. And then 1 hat, 3 t-shirts, and 2 jackets is $180. So I have money plus money plus money is going to equal money. So make sure that your equations make sense. And then again, you would use a system solver to solve for all 3 variables so you can find the price of each individual item. So on these, I need you to set up the system on each of the word problems. and then solve using a solver. So where you're not spending hours upon hours on this, you're just setting them up, plugging in your equations, and then finding your answers. Again, on 2 and 3, I want you to do those by hand. Even though they do have 3 variables, I need you to know the process. And then using a system solver on the other 5, so that way you can get some good practice in.